is a prefix, that means 3. Triangles have 3 sides like a sail on the sea. Quad, a prefix, that means 4. Quadrilaterals have 4 sides like a door. Penta is a prefix, that means 5. Pentagons have 5 sides like a school zone walk sign. Hexa, a prefix, that means 6. Hexagons have 6 sides like a bolt we twist.
Tri means 3 and quad means 4. Penta means 5 and hexa means 6.
Hepta is a prefix that means 7. Heptagons have 7 sides like Orion in the heavens. Octa is a prefix that means 8. Octagons have 8 sides like a stop sign shape. Nona is a prefix that means 9. Nonagons have 9 sides like a Y on a road sign. Deca, a prefix that means 10. Decagons have 10 sides like a starfish in the ocean.
Hepta means 7, octa means 8. Nona means 9 and deca means 10.
Welcome back to today's lesson. So our teachers for today are myself, Miss Morgan, Miss Fisher, Mrs. Spencer Carter, Mrs. Clark Goodfellow, and Mrs. Collins. So today I'll be focusing on the Van Hale level of geometric thinking. So as we know, geometry is the division in mathematics that focuses on lines, points, shapes, and space. Geometry is primarily developed to be a practical guide for measuring length, area, and volume, and is still in use up to now. However, this presentation will focus on the Van Hale level of geometric thought with an emphasis on level 2. This theory was established in the year 1957 by Van Hale Geldof and Pierre Van Hale from the Utrecht University in the Netherlands, who were husband and wife. The Van Hale level of geometric thought highlights how students acquire knowledge of geometry. He speaks about the levels of geometric thinking. So the levels are visualization, analysis, abstraction, formal deduction, and rigor. Let's go again. So we have visualization. You can say it now. Yes, visualization, analysis, abstraction, formal deduction, and rigor. Yes, great. Each level has its own language and symbols. Students accomplish all these levels through a step-by-step process which helps them to achieve better understanding and results. So students, let us look closer to abstraction in formal deduction. At this level, you'll be able to perceive relationships between properties and figures. You'll also be able to create meaningful definitions and also give simple arguments to justify your reasoning. Let us ask Mrs. Spencer Carter to give us a few examples so you can try them.
Wonderful and concise explanation. Now that we have gone through the theoretical aspect, we are now going to move into the practical aspect through a game called 4 in a row. With this game 4 in a row, you will need a card with different sections of angle. And in order to win, you can go vertically or horizontally. So the 4 rows vertically should fill out, or the 4 rows horizontally should fill out. You will also need some counters to mark the different angles. You will need some cards. You will need a bag. So for example, you place the cards in the bag, you shake it. You pick a card, you read the property or properties. An angle measure more than 90 but less than 180. So because we're familiar with that property, we know that it is an obtuse angle. So we are going to mark all the obtuse angle on the chart. Right? There we go. So we shake again. And we pick another card. So with this game, we're not just learning, but we're having fun, right? And angle measure 90. So because we're familiar with the property, we know it is a right angle. It is a right angle. right angle measured 90. And we shake again. And we pick a card. And I'm going to read the property. Each interior angle measures 60. Alright. So because we're familiar again with the property, we know that is an equilateral. Equilateral. So we mark all the equilateral on the chart. So we shake again and we pick. So I'm going to read the property. Measure less than 90. A triangle which consists of 3 dash angles. So we all know that is the acute angle. So there we have 4 in a row vertically and 4 in a row horizontally. Now I am going to tell you the relationship between the acute and the equilateral. So with the acute and the equilateral, all the angles in the equilateral measures 60 degrees. All the angles in the equilateral measures 60 degrees, and the angle for the acute is less than 90. So all the angles in the equilateral less than 90, making the relation between the equilateral and the acute. So they both share the properties where the angles are less than 90.
That was Mrs. Spencer Carter doing the 4 in a row interactive activity. Now remember, you can be creative in using these teaching tools in your classroom. My name is Julian Fisher, and I will be demonstrating how this footloose manipulative triangle wheel can be used to teach your class. Good morning, students. How are you today?
Good morning, Miss. I'm fine.
Great. Great, and I'm fine, thank you. Now today we are going to be learning something new. Can you guess what it is we're going to be learning by looking at this chart?
Triangle, ma'am.
Oh yes, very good, John. We are going to be learning about triangles and their relationship between properties, also measurements. But before we do that, let us talk a little. What do you know about triangles, John?
Not much, ma'am.
Okay, John, not to worry. I will tell you. All angles in a triangle adds up to 180 degrees, and we must remember that. Now let us examine these triangles. What type of triangle is this? Yes, it is an isosceles triangle. How do you know it is an isosceles triangle? These little strokes tells you that these sides are congruent to each other. As you can see, they are both measuring 7 centimeters, and these strokes are used as symbols to tell you that they are both equal. So 2 sides are equal. So on this wheel will be able to fill in the required answers on each line. But for now, we are going to be looking at the equilateral triangle. These triangles measure 8 centimeters. If you look closely, you will see 1, 2, 3 sides, and they all measuring 8 centimeters. Now, Lisa, can you tell me what would we put on this line if all these sides are measuring 8 centimeters? Can you tell me what is the answer for this one?
Gonna have to add it up, Miss.
Oh no, Lisa. Oh no, Kevin, sorry. But in fact, what we'll do is, we know that each side are measuring 8 centimeters, so we'll count the sides 1, 2, 3, and we'll write 3 on this line because all 3 sides are equal. All 3 sides are equal. Okay, another one. Let us look at this one. This one is called a right angle, right? This little thing in the corner right here is a symbol for angle. So in a right angle, you have an angle measuring 90 degrees. So on this line, we'll put one angle measuring 90 degrees. And of course, the sides are not equal. The sides are not equal. If you see, they are not equal. Now, children, there are 3 more left for you to do. I'm going to allow you to do this on your own. And the first person to finish wins a prize. Now go ahead, students. I know your children are bright. Surprise your teacher.
Thank you, Miss Fisher. Now, students, we are going to be looking for properties that are similar in our quadrilaterals, where we're going to be using our quadrilateral card start. I'm going to give you information that matches each diagram. And when I read the information to you, you're going to tell me what diagram to match it with. Are you ready, student?
Yes, miss.
Okay, here's our first one. Opposite sides are equal to each other. Parallelogram bisects each other in center at 90 degrees. Opposite sides are parallel. Can you tell me what diagram this information matches on the card start, please?
I think that's a parallelogram.
Okay, you are absolutely right. These are parallelogram. Stick up. Our next given information would be opposite sides are equal to each other, with diagonal lines meeting at center are also equal on both sides. Only 2 sides are parallel. Can you tell me what diagram matches this given information?
A trapezoid, miss.
Thank you. Well done. Another information. Angles are equal to 90 degrees. Diagonal lines bisect or meet each other at the center at 90 degrees. Opposite sides are parallel to each other, and all angles adds up to 360 degrees. Can you tell me what diagram on the card side this information matches?
That's a rectangle.
Thank you. Other given information. Angles are equal to 90 degrees. All angles. Diagonal lines bisects or meet each other at 90 degrees in the center. Opposite sides are parallel and all angles adds up to 360 degrees. May you please tell me which diagram this information matches?
The information matches a square.
Okay. And we have our final one. Do you think that this information will match rhombus, since we only have a rhombus remain? The information is opposite sides are equal, diagonal lines bisect each other at 90 degrees in center. Opposite sides are parallel to each other. Now think about it. Do you believe that this information given to you matches the rhombus?
Yeah, I think it can match both of it. I think it can match the rhombus and the square, but I'm just going to put rhombus.
Okay. You did well. Now can you look at all the diagrams and tell me the similarities of all of them? Could you give me a summary of all the diagrams that you just presented with an answer?
The trapeze, no, all of them together, they all are symmetrical, and the rectangle, parallelogram, rhombus and square all measure up to 360 degrees.
Okay. Okay, good.
and all of them have 4 sides.
Okay, then good. So there you have it. I'm your facilitator, Miss Nicole Clark Goodfellow, and thank you for having
So
me.
long, farewell to you, students. Goodbye for now. No, 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 no. It's not time to go just yet. Let's wrap up. Informal deduction emphasizes the relationship among properties. Mrs. Spencer Carter gave you an appetizer with an activity called 4 in a row. This activity is a great one to practice with. It classifies triangles by sides and by angles, whether acute, obtuse, right, equilateral, equiangular, scalene, or isosceles. Then Mrs. Fisher, she served you a 2-course meal. The activity she did was footloose triangular wheel. Did you enjoy it? Did you learn from it? Yes, man, I know you did. This activity gave you a visual and an hands-on approach of comparing and identifying similarities in the triangular properties. Did you try to spin the wheel? Tell me, who did? Did you try to spin the wheel? Now, Mrs. Goodfellow, didn't she do an awesome job? She served you dessert. She highlighted the properties with a quadrilateral sort activity. The quadrilateral sort activity, it aids both teacher and the students in understanding the lesson. We oftentimes just look at random shapes and do not put it to reality. But this gives us the properties and the similarities. These activities are activities that will boost students' interest in learning. It will help them to want to learn, and it will help them to remember, to practice learning, practice geometry. As we know, geometry is not that easy if you don't know the first step. Now, students, with all that said, I know you had a wonderful day, a wonderful lesson, so it's time to go now. So long, farewell to you, students. Goodbye for now, until we meet again.